If an airplane flies at an average speed of 7.5 miles per minute, that's really slow, and in 1.5 hours, it will have flown. Okay. What kind of problem do you think we have here? I want you guys to tell me, like, what problem do you think they're trying to situate here?
As a rate.
Yes, there's a rate. And that giant keyword should jump out at you. So we have 7.5 miles for 1 minute. So I'm going to go ahead and write that down. 7.5 miles in 1 minute. And we flew for a total of 1.5 hours. What do you notice is going to be an issue for you?
You have to convert the half.
Okay, you're going to have to deal with the mixed number then the half. Yeah, but beyond that, what is the issue with 1.5?
You have hours and you need minutes.
There you go. They give it to you in hours. You need that as minutes.
So
we're going to have a second proportion to change it. We're going to have a second. Sorry, what was that?
No, I was asking, since like 1 minute is 60 minutes is like an hour.
Yeah, so we're gonna take this 1.5 hours. We're gonna take the 1.5 hours, and I will be nice to you guys. I know you want me to change it to a decimal, so I'll change it to a decimal. So we have 1.5 hours. So this is 1.5. 1.5 hours. We want to figure out how many minutes that's gonna be. And like Cassie was saying, 1 hour is 60 minutes. So we can cross multiply here. Oops, divided the wrong thing. And divide. So the number of minutes will equal to 1.5 times 60. Everything divided by 1, but that's not going to change anything. So I'm going to go ahead and multiply this times 60. That'll be 0.
Is it
0, 30, carry the 3, 9. So this would give me 90. So this is equal to 90 minutes, and we want to figure out how many miles that is. So now we have a second proportion to solve, and we're going to do everything the same exact thing. We're going to multiply first and then divide. So the x number of miles will equal to 7.5 times 90 divided by 1 is not going to change anything. So we're just going to have times 90. So that will be 45, carry the 4. 63 plus 4 is 67? Yeah. And then I need one number behind the decimal. So my final answer will be 675 miles. So again, I think I noticed that you guys are starting to kind of catch like these little details that they try to use to confuse you. So yeah, they presented the problem first with a rate that had minutes, and then they throw you a number that's hours. So always pay close attention to the units. They will always try to trick you by switching up a unit to see if you know how to convert them. Okay, so I'm glad to see that you guys are starting to catch on to those little details. Okay. The next one we have says, a man gets 3 rolls of coins from the bank. Each roll contains $5 worth of coins. If he has one roll each of dimes, quarters, and half dollars, how many coins does he have in all? Oh, okay, this is going to be a few proportions. So the first thing he tells me is that each roll contains $5. So one roll has $5 in coins, whether it's in dimes or in quarters or in half dollars. I haven't seen a half dollar in years, but how many coins does he have in all? So first we're going to figure out how many dimes then how many quarters, then how many half dollars, and then we just have to add everything together. So we need to figure out the number of dimes, the number of quarters. Oh my God, there's like a little mosquito in my house. And we're gonna have the half dollars. Oh my God, if that mosquito touches my face one more time, I'm gonna lose my crap. Sorry. Sorry. Okay, so how many dimes are in a dollar, guys?
10.
So $1, 10 dimes, and we have a total of $5. So how many dimes would we have? We're gonna have 50 dimes. Okay, so far we have 50 dimes. 50 dimes plus. Now let's do quarters. How many quarters in $1?
2.
4.
Sorry.
It's okay. So now I want you guys to tell me, how many quarters should I have if I have $5?
20.
I should have 20. So the quarters, I should have a total of 20. And now the last one, how many half dollars do I have in a dollar?
50 cents.
Well, yes, it's 50 cents, but how many 50 cents do I have in $1?
2. Okay.
2.
2.
2. Because if it's 50 cents, then you need 2 to get to $1. So we're gonna have 2. How many half dollars will I have in $5? I'm gonna have 10.
10.
Okay. Now we just add all these up. That's gonna be 0. That's gonna be 7 plus 1 is 8. So we have a total of 80 coins. So this problem was pretty straightforward, but it seemed like a lot just because we had like 3 conversions to do. I set this up as proportions so that you could understand where the numbers come from. But hopefully you guys are able to see that if you're converting from a small unit to a bigger unit, you're going to need to divide. And if you're going from a big unit to a small unit, you're going to need to multiply. So the proportion will always work. It is like your best, it's like the strategy that should be your best friend by now. But if you know already, well, I'm going from like, dollars to coins, so I should multiply, then you're good. You don't have to write a proportion every single time. I do it just so you guys understand where the values are coming from, but you don't have to do it every single time. Hopefully you're gaining that confidence to be able to kind of figure out, oh, I'm going to multiply or I'm going to divide. And if you're confused, do a proportion. Any questions on this one before I move on to the next one?
Nope.
Okay. All right. So these, I believe, are some math knowledge ones that you guys sent in. So this one says, 2 parallel lines are intersected by a third line, which is perpendicular to the first parallel line. The value of another angle made by the intersecting lines is, wow, okay. There's a lot of vocab here. So one of the first things that catches my attention is that they mention parallel lines, and they mention intersected, and then they mention perpendicular. Those are some big math words. So let's talk about them a little bit. So parallel means 2 lines that are going right next to each other and they never cross. It's like the railroads. Like they're never going to just randomly go crack. No, they're going to never touch each other. So you have 2 parallel lines. Intersected is a really fancy word for crossing. So you have 2 parallel lines. So let's say these 2 lines right here. They're never going to cross. And parallel lines are symbolized by like these little matching tattoos. They're like little arrows that they have in the middle. And they're intersected. In other words, they're crossed by a third line. And they mentioned that that third line is perpendicular. Perpendicular means that when the line crosses, it creates a beautiful 90-degree angle. So it's going to cross exactly like wham, across. And it forms a perfect, beautiful 90-degree angle. Wherever it touches another line, it's forming a 90-degree angle. So the value of another angle made by the intersecting line is, well, the intersecting line is creating beautiful 90-degree angles. So that would be your answer. So it's a very straightforward problem. What it requires is you understanding the vocabulary of like what's parallel, what's perpendicular, and what's intersecting. So again, parallel means, parallel, I like to think of it as like the two L's in the middle. They never cross. Never cross each other. Perpendicular is the complete opposite. Perpendicular. Perpendicular is the complete opposite. It crosses and forms 90-degree angles. And like I said, intersected is a fancy word for crossing. Okay? So, are we clear with that one? Are there any questions? Anything that confuses you?